We left off in the previous video with a maximum fill rate so that we could control the rate at which the bathtub filled over time. So it filled gradually based upon the defined maximum fill rate and then slowed down until finally when the bathtub was full, the flow stopped completely. As per where we've left this, there is an error in the model that I didn't realize that does in fact need to be fixed. Maximum fill rate is in fact not in gallons. It needs to be in gallons per minute because it is in fact a flow and not a stock or the equivalent of a flow. So I can define this. I could change this, either make this in gallons per minute, which is a little difficult to do because it's not really a flow. So rather than do that, let's just call this max fill, and so it's not actually a rate, and that way I won't have to change the formula itself. But we could in fact say we want to define how fast we can drain the tub, so we can define a slider for that and say that it varies from 0 to 5. So now we have a slider for max fill and for drain, and we can define one for what we define as the full level of the bathtub, and we'll say that could go from 0 to 100, and those are probably the things that we would be most likely to want to change as we interacted with the model to investigate the way that things played out. What's important to realize here is that we have full level, which essentially represents a goal. It's a state that we're trying to reach, and we have a current state of things, the amount of water that's in the bathtub, and it's the difference between those two things that creates a gap, and it's that gap which influences action intended to move the current state toward the desired state. This is a typical interaction structure that one sees in models all the time, or in all different kinds of interactions. And what the structure is trying to do is it's trying to bring the current state to in line with the desired state. And so what this structure does, not taking into account these two pieces down here, but these parts of the structure, the bathtub, the full level, the gap, and the flow, it's trying to create a balance, and we typically identify those within a model, and we'll call this B1 balance, to say that this is a balancing structure, and we create this loop going in the direction of the balance. And I'll make this a little bit smaller so it'll actually fit where I want to put it. Now, why is this a minus? Because as the full level increases, it would cause the gap to increase. So this sort of adds to or moves in the same direction. So I would go ahead and color this as blue. As the gap increases, it would tend to cause the faucet to increase, so I would color that blue. The faucet actually, what the flow of water adds to the bathtub, so I would color that blue. But the level of water in the bathtub subtracts from the gap. Full level adds to, and this subtracts from. This makes it smaller. So this part I would color as red. When you see this in other diagrams, other notation, there are often plus signs and minus signs used as notation, and you could do that with the text tool if you in fact wanted to. It's just a little tedious to create little indicators to put on the model, but you could, and I have, though I personally just tend to code them as red and blue. It's I think it's as easy to recognize as the plus or minus signs. So because this is attempting to bring it into balance, it's a balancing loop, and there's a minus, there's a subtraction in the sequence. If I count the influences around the loop and they are odd, then the loop is a balancing loop. If in the next model that we do in the next video, we'll deal with a structure where all of the influences in the loop are adding, and that will end up being a reinforcing loop as opposed to a balancing loop. So what we end up with is a structure which is typically referred to as a balancing loop, which has a balancing feedback, often called negative feedback, and negative is a term which more often than not simply confuses the situation, because it subtracts from this, but it's not negative in a bad sense. It's negative in a balancing sense. And in this particular situation, you want negative feedback, balancing feedback, to control the flow into the tub so that when it gets full, it stops filling up. So so we call it a balancing loop, and the structures are, or the icons are built into Insight Maker for reinforcing loops clockwise, counterclockwise, and balancing loops clockwise and counterclockwise. I said that if you count the influences around a cycle and there are an odd number of balancing feedbacks, it's a balancing loop. If there are 0 or an even number of balancing feedbacks, then it's a reinforcing loop. So this allows us to, well, this is one of the basic structures that is used to create all models. As I said, this is the balancing loop, and because of the maximum fill rate, this is actually a limit to the results. So this structure itself, this is the goal, this is the current state, and the action, the flow of water, creates a result, and the maximum fill aspect of the model that we have built actually represents a limit on the rate at which those results can be achieved. If you noticed in one of the earlier simulations where the tub went from empty to full in 1 minute, there was in fact no limit to results on the model at that point. Though as we've continued to elaborate the model so that it gets closer and closer to a real situation, max fill level represents a limit placed upon that action to move the results closer and closer to the goal. So I think that's about it for developing the bathtub model. The important points being that you build in little pieces and you test them as you go, and you think about how it should behave when you simulate it, and once you simulate it, you attempt to understand, is it doing what you think it's doing? Do you need to educate the model, or is the model educating you? And we'll pick it up in the next video, and we'll talk about a reinforcing structure and talk about how money makes money. Hope you enjoyed it. Bye.